we're going to look at subsequent applications of being able to work in MATLAB with our derivative. And one of those is being able to find the rate of change or the slope at a specific point. It's actually going to be fairly easy because all we're going to do is just find the derivative and then substitute a value into that derivative. And we're going to use this function subs using the three parameters f, which is the function, the old variable, and the new value to be substituted into that variable. And so really basic code is that if I symbolically define x and f, if f is e to the x times sine x, we assign that value, or we assign to the derivative or to the variable deriv diff f comma x, and then we substitute back in deriv back in for x the value 0, and that helps us to find the slope at the point x sub naught equals 0. So just looking at two pretty basic examples, we're going to go through and find the rate of change at the given point. So we're going to start by having this function, polynomial function g at t is 3t to the fifth, 2t cubed, 4t squared, t 15. And we're going to try to find the derivative or the rate of change at negative 0.5. So here's how we're going to do that. We're going to start with sims of f and t, and we're going to define f to be the function 3 times t to the fifth plus 2 times t to the third plus 4 times t squared, and then plus t plus 15. We're going to assign deriv to be diff of f with respect to t, just like we did in the previous examples. And then finally, we are now going to substitute back into deriv. The former variable was t. The new value, remember, is negative 0.5. And that's going to just go through and find the exact value of the slope, which is negative 9/16 at the point of this function. All right, so pretty cool that we can do that really. A second example might be a little tougher for us, is that we have a function p of x, arc sine of x over root 1 minus x squared, and we're going to try to figure out what the derivative is, or the slope is, at root 2 over 2. All right, so we're just going to go through. I'm going to delete all of this, and instead of t, let's have an x. Let's define our function a sine of x divided by the square root of 1 minus x squared. So that's our function. We're going to find the derivative, and we're going to assign it to the variable deriv. So we're going to assign derivative of f now with respect to x. And now we're just going to use the subs function. So substitute back into deriv. Old variable is x. New variable is square root of 2 divided by 2. Right? And we're going to execute. And we get this value, pi halves plus 2. And that gives us the exact slope of the function at the value x equals root 2 over 2. So pretty cool that we can do that just by using our subs functions. In the next videos, we're going to take a look at how we can analyze the graph of the derivative, just like we did analytically, except we're just going to use MATLAB to kind of give us an idea as to what to expect with that.